Howdy, kiddos. It is almost Halloween. It is October 26th. I'm making this video. You won't see this video until something like November 10th. So I'm not as far ahead as what I was. I hope that you realize at this point, man, these videos are kind of important. So I want you to realize, and I was telling my algebra kids this today, we have 90 days in a semester, but I only see you 45 days. So I've somehow got to teach 45 days worth of material when you're not here. That's why it's extremely important that you watch these videos, okay? So basic properties of similarity. The key to similarity is, okay, two things. One, all angles must be congruent. And there's that word again, congruent. Congruent means exactly the same. So even though triangle ABC and on this triangle A prime, B prime, C prime look to be the same shape but have different sizes, the angles must still be the same. We can't test that with this one, but if you had a protractor, you better be able to check that and make sure that all the angles are exactly the same. So if A is 30 degrees, A prime better be 30 degrees. If B is 90, B prime better be 90, okay? So all angles must be congruent to the corresponding angle. And number two, this is what is important from today's lesson. So number two is what's important. Where's my, let's go this way a little bit. There we go. Each side length should stay proportional. Well, Mr. H, what do you mean by that? Well, that's a good question. So that's what we're going to do here. Okay? We need to prove that triangle ABC is similar to triangle A prime, B prime, C prime. Okay? And then we're going to go backwards and prove that A prime, B prime, C prime is similar to triangle ABC. Okay? So what do we need to do first? Well, we need to find a scale factor. To do the scale factor, I'm going to say AB divided by A prime, B prime. That has to equal the same as BC divided by B prime, C prime. Look, I'm doing these backwards. If I'm going from the big to the small, okay, remember it's always the image divided by the pre-image. Where's my marker? And I should probably put that up here. It's always the image divided by the pre-image. Would help if I even knew that, right? So we're trying to see if this is similar. Notice that from A prime or ABC to A prime, B prime, C prime, it shrinks. That's called a reduction. So now I've got A prime, B prime divided by AB. Image, pre-image. B prime, C prime divided by BC. And A prime, C prime divided by AC. This is what it means to be proportional, because this is how we find the scale factor. Remember, the scale factor is the image divided by the pre-image. So let's start substituting in. A prime, B prime is 2, divided by AB, which is 4. B prime, C prime, 3, divided by 6. AC is 4. Hold on. Yeah, I'm good. 4 divided by 8. Okay. You should have your calculators. See what each of these equal. 2 fourths, 3 6, 4 eighths. All of these give me a scale factor, which Engaged New York calls R. So scale factor of R of 1/2. If they're all the same, if they are all the same, if they are all the same, if they are all proportional, the scale factors are all the same, then they are similar. So right now we can say that triangle ABC is similar to triangle A prime, B prime, C prime. Well, what about the reverse? What if we were going from this to this one? Why is it going to stay similar? Well, the proportion simply becomes inverted. And by inverted, I mean flip it end over end. So we had 2 fourths, now we have 4 halves. Well, what happens here? My scale factor, which is R in Engaged New York, becomes 2. Are they all the same? Yes, they're proportional. So if one triangle is similar to the other, then it works the opposite way. Okay? So as soon as we know something is similar to something else, one triangle is similar to the other, we know that the other triangle is similar back to the first one. So two things. Either all the angles need to be congruent and correspond to the other one. So A matches up with A, B, C with C. Or we can say that all of the side lengths are proportional. The scale factor stays the same. Okay, well, let's keep going. Let's see what we have. Oh, okay. So first, determine whether or not triangle ABC is in fact similar. Yeah, we did that. Use a protractor to verify that the corresponding angles are congruent. I'm telling you that the angles are congruent. Why? Because I've proven that the scale factors are proportional. Therefore, it's going to be similar. But now we come to this one. Describe the sequence of dilation followed by a congruence that proves triangle ABC is similar to triangle A prime, B prime, C prime. Okay, so now this is the first one. So I'm going to get rid of all of this. And now we're going to say, okay, we've already proved that it's similar. We've already proven that it's similar. But how can I get from here to here? Well, we already know that it's a scale factor of 1/2. So I need to show that this point is at 6, -4. So now if I take this by 1/2, it's 3. -4 by 1/2 is 2. So I get 3 -2 is A. Then this is at -8, +4. So 1/2 of -8 is 4. Hold on. What did I just do there? 3, oh, shoot. Did I do this right? -4 is 2. Oh, no wonder I did this wrong, Mr. H. This is -4, 6. There we go. Which still gives me -2 up 3, which is fine. That's where A was anyway. Okay. So now B is at -8, +4. 1/2 of -8 is -4. 1/2 of 4 is +2. So there's B. And last but not least, C is at -6, -2. 1/2 of that is -3, -1. Okay. Well, how can I get this figure to this one? So, step 1, because we are on letter B. Remember, letter B said, determine the sequence of dilation followed by a congruence. So the sequence so far, let's move this down a little more. Is it there? Oh, it's there. Okay. So far, we've dilated by R equals 1/2. So we had to know the scale factor. And we've been doing that in all of the other lessons. So we're good with the scale factor, or we should be. So now it's here. Well, how do I get this guy over here? Well, we are going to rotate. And it doesn't matter because we're going to go 1, 2. We're going to rotate 180 degrees. Even though we don't know what point exactly we're rotating around, we're going to rotate this around 180 degrees to get up there. Probably somewhere around this point. Okay? Because it needs to turn once, which turns it sideways, twice, which turns it up. So C comes up, A comes to the bottom, B comes to the side. If you need to take your paper and turn it, that's the best way to check it. That's our sequence. Okay, well, what else, Mr. H? Good question. I don't know. So this one is asking us to do it backwards. Well, we already know that once something's similar, they'll always be similar. Okay. Oh, man, this is a tough one. This is a tough one. So now we're on exploratory challenge number 2. We know, let me keep that image divided by pre-image. Pause for 1 second. You're still working on my letters and you're going to put them up? Perfect. Okay, so describe the similarity that proves triangle ABC is similar to A prime, B prime, C prime. Okay, so we're proving this one to this one. Image, or pre-image, image. Our pre-image is the one that does not have the primes. So my image is 6 3/10. That's AB, AB, 2 1/10. 3 divided by 1. 9 divided by 3. All of those, if we take our calculator and we divide, my scale factor, which is R, is 3. Does that make sense? Did it enlarge from ABC to A prime, B prime, C prime? Absolutely. Okay, so that's an enlargement. So describe the similarity that proves this. Enlargement with dilation of R equals 3. Okay, because this point's -1, 2. It's now -3. So here we are. So that's my similarity. Wait for what happens when we come to the sequence. So I'm guessing letter B says, what sequence takes us up there? Let's see. Am I right? Let's see. Describe the similarity. I don't want that yet. We're going to skip that one. Oh, I guess we're going to need to do that one. So now describe the similarity that proves triangle A prime, B prime, C prime is similar to A double prime, B double prime, C double prime. So now I'm trying to prove that this one is similar to this one. Okay. So this is my now pre-image. This is my following image. So AB is 6.3. AB is 4.2 divided by 6.3. Why? Because this is my image. This is my pre-image. We're going from the pre-image to the image. So now A6 divided by AC, which is 9. And BC is 2. BC is 3. Okay, get your calculators. 4 and 2/10 divided by 6 and 3/10. All of those will divide and give me a scale factor, which we call R is 2/3. So we know that ABC is similar to this one. We know this one's similar to this one because they keep the same scale factor. Okay, that's important. That is extremely important. If this is similar to this and this is similar to this, we know this guy is similar to this guy. Okay, similarity doesn't change. As soon as one thing's similar to something else, they're all going to be similar to all the other things. Mr. H, this isn't making much sense. Yeah, we're going to practice it, I promise. So now we're going to verify it using side lengths, corresponding angles. Yeah, we just did that.
Aiden Lyle to the office, please. Aiden Lyle to the office.
So is it true? Why do you think this is so? So now we're going to prove that it's true. And here's how I'm going to prove that this is true. So I'm going to leave my scale factors there. But now I'm going to use scale factors and our transformations, our rigid transformations. So step 1, to prove that this is true, I enlarge by R equals 3. So if this is at 0, -3, it stays at 0. My scale factor is 3, so it goes to 0, -9. So this is now C. B is at 3, 1, so -9 times 3. So here's my 3. That's B. And A is -1, which goes to -3. 2 goes up to 6. And here's C. So here's the same figure after the enlargement. Okay, so once I have that enlargement, how do I get it up to the next one? Oh, well, we have to translate, Mr. H. Yeah, you do. You know why? Because you have to slide this. Here's B. How many do I have to slide to get up to B? 1, 2, 3, 4, 5. So I translate up 5. So now we're here. So we've now gone from A, B, C to A prime, B prime, C prime. This gets me from A, B, C to A prime, B prime, C prime. Those 2 steps do that. Well, we're trying, though, to prove that this is similar to this one. So now what do we do? I keep trying to grab my mask thinking that's my cloth, and it's not. So now we need to dilate by 2/3. Okay? So that means shrink it down. So when we shrink it back down, so now we're dilating by 2/3. Why are we dilating? Because to get from here to here, the scale factor is less than 1, which means we have to shrink it down. Last but not least, how do we turn this guy? Oh, we rotate it And this is where you're going to use your paper. We rotate it. Which direction? To the right, which is clockwise, by how much? 90 degrees, because it's only one turn. So this gets me from ABC to A prime, B prime, C prime. The second one gets me from A prime, B prime, C prime to A double prime, B double prime, C double prime, which is proving ABC gets me to A double prime, B double prime, C double prime. Let me be very honest. Are you going to have this in the real world? No, not very often. Is it going to be on your map test? You bet your bottom dollar. You're going to see similarity on your map test. Sometimes I would love to say, oh man, here's when you're going to use this in the real world. Yeah, I'd love to. You're going to need it for the test. I'm telling you that very honestly, you're going to need this for the test. Okay? So the lesson summary says a lot of big words that don't make sense. So similarity is a symmetric relation. That means that if one figure is similar to another, then we can be sure that it works the other direction. The transitive relation says that if ABC is similar to A prime, B prime, C prime, and A prime, B prime, C prime is similar to A double prime, B double prime, C double prime, then ABC is similar to A double prime, B double prime, C double prime. We'll practice in this class. Make sure you've taken good, solid notes. Thanks, guys. Where are we?